Okay, so let's make sure you're on the right track here. So they're asking for what percentage of U.S. households had an income of 55,000 or more. So you correctly identified the right column. You said there's the mean of 21,000 with standard deviation of 37,000. So therefore, we're saying what's the probability that somebody, the x value, is greater than or equal to 55,000. So we don't want to deal with x values, we want to deal with z values. So we convert that into the number of standard deviations away from the mean. Perfect. So the value minus the mean divided by the standard deviation gives you, assuming your math is right, 0.91891. So what this means is the number of standard deviations from the mean. Okay, so now what we need to do is interpret this. And this is not what I understood your other question to be, so I'm glad you asked, because now I understand where the real problem was. You didn't understand the z-table, or that we need a z-table. So the z-table is now posted for you in the section 8.5 or not section 8.5, it's whatever, unit 15 or whatever it is, but it's under that, wherever this came from, in Canvas. You can also get it from your book. It's in the appendix section. I believe it, I don't remember. But it's back in the appendix. But I gave it to you as a download. Excuse all this writing. This is what I used in the lesson that I just did. But your z-table is going to look something like this. So what we're going to look for, well, first thing we got to understand is how to read the z-table. The z-table is giving us values. When you find a b value, it's giving you the area from 0 to b, from the mean to b. So what you've got going on here, we're asking for numbers greater than. We don't want from the mean to b, we want greater than. So your b is 0.91891. So when we go here, we're going to find that value. So 0.918. Now notice the level of accuracy. This column goes to tenths place. This column here goes to hundredths place. So we're just going to, for this class, we'll just round it, and that'll probably get us close enough. So we'll just call it 0.92. So let's find 0.92. So as we go down, here's 0.9. We're going to go across to get to the 2. So we're looking at this value right there. So for our table, we know, if you imagine it's a, there we go, 0.3212. Okay, so for ours here, for our normal curve, they are saying from the mean to, actually that's the wrong mean, but that's beside the point, to our value of 0.92, the z value, the probability of being in there is 0.3212. So now the question here is, if we understand that the normal curve covers 100% of the data, or the probability of being under the curve is 1, you're going to have some value, and we want to know how many people are from here and up. Well, if the mean from here and up is half, 0.5, how would you figure out what's in this area down here? Well, so now the idea is pretty simple. It's just if from here on up is 0.5, we need to take away that portion. So this section will be 0.5, take away 0.3212. And that's going to end up giving us 0.1788. And I believe the problem asks for it rounded to the nearest. Let's go look. Rounded to the nearest percent. So again, so if this is 0.17, that's 17%. So rounded, that would make it 18%. So there's your answer. I hope that cleared it up. I hope that gave you what you needed. I didn't realize that where your problem was reading the z-table. So let me know if that's good enough.